Hi students, we are in the ideal gas law section. So we need to relate pressure, volume, temperature, number of moles, and the universal gas constant to each other. So we've got P, V, N, R, and T. And that gives us PV equals nRT and a new variable here, sorry, not variable, a constant, R. And because R is a constant, it's constant. So it's constantly 0.0821 if you're using ATM. And it's 62.4 if you're using millimeters of mercury or torr. Because remember, millimeters of mercury and torr are the same thing. So we take a look at R down here, and you can see that it's got a pretty big and ugly looking unit made up of 4 units. It's got liters, it's got a pressure unit in there, ATM, millimeters of mercury or torr, and then the denominator, it's got moles in Kelvin. But don't worry, we'll figure out how to work with that, and a lot of those will cancel out and it'll be okay. So this brings us right to problems. And number 1 says Rosie has a 5-liter tank of hydrogen gas. If the pressure inside the tank is 800 torr and the temperature is 300 Kelvin, how many moles of hydrogen does her tank contain? Now remember, the math in this chapter isn't that hard. It's keeping all of the equations straight. So if we just come upon a problem like this, and we're not in the ideal gas law section, so we don't know that that's what we're supposed to be using, we might start by identifying our variables. So 5 liters. Liters is a unit of what? Of volume. So we've got V, and then we have 800 torr, and torr is a unit of what? Of pressure. So we've got P here. And it says that the temperature is 300 Kelvin, so we know that's T. And we're looking for moles, and moles is lowercase n. And that's all it gives us for this problem. We're used to having 2 V's and 2 T's and 2 N's or 2 P's in order to solve problems, or STP, which would mean that 1 mole of gas would be 22.4 liters. But when you only have one of your variables and you don't have STP, that should give you a clue that you're going to use PV equals nRT. And then what we'll do is we'll say to ourselves, okay, which R do we use? And the R that we choose has to do with which pressure unit we have. But before that, let me go ahead and list our variables. So we have P, V, N, and T. And our pressure is 800 torr. Our volume is 5 liters. Our number of moles, we don't know that. It says how many, so we'll put a question mark there. And our temperature, 300 Kelvin, and that's good. It's already in Kelvin. We don't have to convert it from Celsius or Fahrenheit. And then we're going to say, okay, we've got one of each of these. We don't have STP, so it must be PV equals nRT. And we need to solve for n, and if we use the magic of algebra, we'll get that n is equal to PV over RT, and then we can just plug and chug. And our pressure is 800 torr, and our volume is 5 liters, and R. So we have to come up here and we have to decide which R that we're going to use. And we can see that we've got torr right here. So we're going to use the R value that has torr in it. And remember, you can use millimeters of mercury or torr interchangeably. So what we do is we put that whole gigantic thing on the bottom down here. So we have 62.4 liters times torr. We don't use the millimeters of mercury because we want the torrs to cancel out. Times divided by mole times Kelvin. And then we still have to put our temperature in, which is 300 Kelvin. And then we look for things that cancel out. So we've got a torr on the top and bottom. We have liters on the top and bottom. We have Kelvin on the top of the bottom and on the bottom of the bottom. And so those cancel out. And we have a mole on the bottom of the bottom. And that means it gets a ticket where? On the train to the top. So we're going to have moles on the top. And in one of our other lecture videos, I showed you mathematically how that works out. And we all agreed that we would trust me from here on out, that if you're in the bottom at the bottom, you get to go to the top. And then we go ahead and put 800 times 5 in our calculator. And at that point, I hit equals. And then I do divided by 62.4. And I usually hit equals again because I like to hit equals a lot. And then I'd hit divided by 300 and then hit equals again. And I would notice that I've only got 2 sig figs right there in that volume. And so that means I'm going to end up with 0.21 moles of hydrogen gas. Now, what happens if the question had asked us to do grams of hydrogen gas? Well, we're already in moles of hydrogen gas, so we can just use the molar mass of hydrogen to go ahead and get to the grams of hydrogen. So we'll go ahead and put our given there. And molar mass is grams per mole. So 1 mole of H2 weighs how many grams of H2? And you would look on your periodic table and you would see that each hydrogen weighs 1.008, which is pretty close to 1.01, and we've got 2 of those. So that ends up being 2.02 if we had 1.01 plus 1.01. And the moles of hydrogen cancel out, and you do 0.21 times 2.02, and we would get 0.42 grams of hydrogen. Now the question didn't ask for that, but it's really easy to go to that, so I wanted to show you that. All right, so Chris's favorite meal is a bean and cheese burrito from Del Taco with extra red sauce and extra cheese, with a side order of macho fries, well done and extra salty. Yum, 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 delicioso. Unfortunately, this means that his intestines will fill with 1.5 moles of methane gas, which is flammable under 2 atm of pressure. What is the volume of gas that occupies his bowels? Make an assumption about temperature. Okay, so just listing them in order, I've got 1.50 moles of gas, and 2 atm, is that P, V, or T? That's P. That's a pressure unit right there, atm is, and it says of pressure anyways right there. And then it says what volume, so we're looking for our volume. And T, make an assumption about temperature. Well, the gas is inside his body, so the gas is most likely at body temperature also, which is 98.6 Fahrenheit. And if we did the calculation, that would be 37 degrees Celsius. And to go from Celsius to Kelvin, we add how much? 273. So that gives us 310 Kelvin. And we also need an R value here. And our R value has to do with the pressure unit there. So if we look back up here, we can see that whenever we're using ATM, we're going to have 0.0821. So it's not 62.4. You use 62.4 when you have torr or millimeters of mercury. So 0.0821. And that's liters times ATM over moles times Kelvin, or Kelvin times mole, either way, and I got that from right there. Now we need to rearrange our equation. So we have PV equals nRT, and we're solving for V. So V equals nRT over P, and now we can just plug in check. So N is 1.5 moles, and R is 0.0821 liters times ATM divided by moles times Kelvin. And then we have temperature, and temperature is 310 Kelvin. And we're going to divide that by pressure, which is 2 ATM. Okay, so what cancels out? Well, we have mole and mole, and we've got Kelvin and Kelvin. We have ATM and ATM, and we're left with units of liters. So that makes sense because we're solving for a volume, and liters is a unit of volume. And then we go ahead and we put this in our calculator, and we notice that here we used a temperature that has 2 significant digits. Now, if the problem gave you a temperature with 3 significant digits or 4 significant digits, you could go with that. But we did 2 significant digits there, with that 0 being not significant, so we'll go with that. And our answer would be 19.088, and that rounds to 19 liters if we're doing 2 sig figs. And that means that Chris is a very unhappy person because 19 liters of gas is a whole lot of gas. Just think that one of those big containers of soda is 2 liters. So if you had that much gas inside you, you would be in pain or exploding. And that wouldn't be very nice to sit next to Chris while he was exploding. Okay. So, number 3 says Jesse wants to cook up some steaks for Super Bowl Sunday. He looks at his barbecue and notices that his propane tank contains 10 liters of gas under 3 ATM at room temperature. How many grams of propane does Jesse own? Okay, so we know we're in the PV equals nRT section. So let's see if this holds. So PV, N, R, and T. Okay, what's our pressure? So looking through this question, we see 3 ATM. So we'll go ahead and write 3 ATM there. And our volume, we've got 10 liters. And our moles, we don't know that. And the question doesn't ask for moles either. It asks for grams. But if we solve for moles, can we get to grams? Yes, we can. So we're going to go ahead and solve for moles first, and then we're going to worry about going from moles to grams a little bit later. Okay, so we are in ATM. So the R we're going to use is the R that goes with ATM, and we have 0.0821, or as the other slide said, 0.082. Liters times ATM over mole times Kelvin. And it says it's at room temperature. Now, room temperature is one of those things that we just kind of learn in science, that it's 25 degrees Celsius. Whether it's 25 degrees Celsius in the room you're sitting in or not doesn't matter. Room temperature in science is 25 degrees Celsius. And what we do is we add 25 degrees to 273 degrees because that's how we get to Kelvin. And when we're working with gases, we need to be in Kelvin. And that gives us 298 Kelvin. Okay, so PV equals nRT, and we're solving for N. And that will give us PV over RT, and then we plug and chug. Okay, so N is equal to the pressure, which is 3 atm, times the volume, which is 10 liters, divided by our R, 0.0821 liters times atm divided by mole times Kelvin. And then we multiply our R by our temperature, and that is 298 Kelvin. And then we look at this and we say, what can we cancel out? So we've got atm that we can cancel out liters, and we can cancel out Kelvin. And then we have moles in the bottom of the bottom, and that gets to pop up where? Into the top. And that's a good thing because we're solving for N, which is moles. Okay, so we go ahead and we put all of that into our calculator, and we are going to get that N is equal to 1.23 moles of propane. And propane is C3H8. Okay, now that is not our answer yet because the question says how many grams. But we know how to go from moles to grams because we've been practicing this a whole lot. So moles of C3H8. And if you want to get rid of moles, then you need to put it in the bottom. And if you want to go 2 grams, then you got to put it in the top there. And this conversion factor right here is the molar mass of propane. And what you guys would do is you would get out your periodic table and you'd say, okay, a hydrogen weighs 1.01. And so you do 8 times 1.01, and you would say plus, and then you'd open up parentheses, and you put 3 times 12.01 because carbons weigh 12.01, close the parenthesis, and hit equals, and what you should get is 44.09. So pause for a moment if you guys have to, and make sure you're getting that so you can do it on the final exam. Okay, so we cancel out our moles of propane. And we multiply, and we've got 3 sig figs, so we're doing 54.2 grams of propane. And that there would be our answer. So again, with the sig figs, you've got 3 sig figs here. And here we've got 4 sig figs. And right there, that 1, that's exact. So it has infinite number of sig figs. And that means, my friend, we are done with this section. So in the next lecture, we'll go on to Dalton's law, and that's a law of partial pressures. And I think you're really going to like that section. Okay, until then, bye-bye.